Today we'll be discussing probability, and we start with the introduction to sample space, events, and probabilities. An experiment is a process that generates well-defined outcomes. For example, in tossing a coin, you have two outcomes, the head and the tail. Or rolling a die. For a single die, remember, there are six faces, and for any roll, there are six possible outcomes. It can be outcome 1, 2, 3, 4, 5, and 6. Or another example, when you are applying for a job, you are either accepted or not accepted. I would like to say rejected, but it's a bit harsh. So there are two possible outcomes. A positive outcome, which is accepted, and a negative outcome, which is not accepted. Or in an election, there are again two outcomes. One is win, the other one is lose. Each of these outcomes is referred to as a sample point. So for an experiment with n sample points, you label them as E1, E2, E3 until you end with En. For example, in rolling the dice, you have six sample points, so therefore you have E1, E2, E3, E4, E5, and E6. The sample space S is a set of all the experimental outcomes. So the sample space of an experiment with n sample points has S equals E1, E2, E3 until the last sample point, En. Notice that you need to place the set inside the bracket with each sample point separated by a comma. What is an event? An event is a subset of the sample space. It is a collection of sample points. For example, in rolling the dice, there are six sample points with a sample space S equals to 1, 2, 3, 4, 5, and 6. But an event can just be a subset of the sample space. For example, the event can just include three sample points, like E equals 1, 2, and 3. So what then is the probability? The probability is a numerical measure of the likelihood that the event will occur. In this example, therefore, the probability of the event with a sample space 1, 2, 3 will occur will be equal to the sum of the probabilities of 1, 2, and 3. The probability of an event E is written as P enclosed in parentheses E and pronounced as P of E. If P of E is 0, this means that the event E cannot occur. While if P of E is equals to 1, the event E is certain to occur. There are two requirements for assigning probabilities. Number one, if EI, the ith outcome of an experiment where I equals 1, 2, and until n, for all sample points or outcomes, for EI, therefore, the probability of the event is greater or equal to 0, but lesser or equal to 1. And number two, the sum of the probabilities of all the outcomes equals the summation of probabilities from I equals 1 until I equals n is equal to 1. That is probability of E1 plus the probability of E2 plus the probability until you reach the probability of En equals 1. For example, when you flip a coin, you have two outcomes. It's either the head or the tail. And so your sample space is equal to H and T. The probability, therefore, of each event to happen, since there are two outcomes with two possible events, the probability that each event will happen is just 50% or one half. So you have, therefore, P that the event head will occur plus the probability that the event tail will occur is equal to 1. So for example, you want to roll a dice and the dice has 10 sides. So therefore, n would be equivalent to 10. And the sample space S will start from 0 until 9. Enclosed in the set is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, the probability that each side or each event will occur is 1 over 10. And when we express it mathematically, we have the equation probability of 0 plus the probability of 1 plus the probability of 2 until we reach the probability of 9. That's equivalent to 1. Imagine having a sample space of throwing 3 dice, which has 216 entries, or a sample space of throwing 4 dice, which has 1,296 entries. If you are going to do a manual computation, that is, you manually calculate from 0 to 215 or 0 to 1,295, that would just be too much for an ordinary soul. In other words, we deserve the counting rules. To understand the counting rules, we need to know that there are some basic probability relationships that can be used to compute the probability of an event without knowledge of all the sample point probabilities. Like, for example, the union of two events, intersection of two events, mutually exclusive events, conditional probability, independence, and the Bayes rule. So, guys, on the next video, we'll be discussing the counting rules. But please subscribe to my channel. And of course, please also hit the like button. Thank you.